broadcast. And also, I'm going to go ahead and start the poll. General multiple choice. Yeah, that's right. All right, that's fine for now. All right, gentlemen. So I can't think of any real announcements. We're at the top of week 10, right? So I think we were working on 2.2 polynomial functions. And so today, or sorry, we're at the backside, the end of week 10. So today we'll be working on the homework for this section. And usual rules apply. If you have questions, feel free to unmute yourself and let's just hop into this material. Okay. There you go, thank you. Come on, that's so irritating. Thank you. Okay. So this question comes from section 2.2, question number 1 from the back of the text. This says, consider this polynomial, write the degree of this polynomial, is leading term, is leading coefficient, and its constant term, right? Anybody confident to tell me the degree of this polynomial? What's the highest exponent on any variable? What's the degree?
X to the 5th power. 5,
right? The 5th power. Let's turn this off. And the degree is the highest power, so it's going to be 5. Okay, that was good. What's the leading term, right? So terms are things that are added and subtracted. And the leading term is a term with the highest power. So that means the leading term is?
2x to the 5th power.
2x to the 5th power, let's see. Okay, so if that's our leading term, then what's our leading coefficient? So the leading coefficient is the number in front of the leading term. So in this case, come on.
2.
What's that? 2, right? If I can get my keyboard to behave. Okay. And the constant term is a term without a variable. So in this case, that's going to be so the constant term is what? -6, right? Just for the sake of time. Okay. Why did she send this? Why is it not showing here? Okay. For the following polynomial function, find the degree, the leading term, and the leading coefficient. Okay. So the degree is the highest power. Any takers? Going once, going twice. 7. Okay. The leading term, so you might want to distribute that 1/3, right? Because we're dividing by 3. Because we're dividing by 1 term, we can distribute it into the top, right? So that's, instead of that being 2x to the 7, that's really 2/3 x to the 7. The second one is really 5/3 x to the 5th. So the leading term is going to be 2/3. All right, I guess I got to zoom out for that to behave properly. All right, well, let me try to work with this. 2/3 x to the power of 7. I can't see it. That's fine. Okay. The leading coefficient is what? 2/3? 2/3? Okay. The degree, the highest power. Oh, that was creepy. Highest power is 3. Come on. Okay. The leading term is pi/2 x to the 3rd. Let's see. pi/2 x to the power of 3. Okay. Leading coefficient is what? Pi/2. Pi/2. Okay. So these are, okay. So remember, I think one of the one of the properties we said that polynomials, the graph of the polynomial will have is going to be smooth, so it's not going to have, there are no sharp edges, corners, or anything like that. The absolute value term is going to create a sharp corner somewhere on our graph. So it's not a polynomial function because of the presence of the absolute value of x. Okay, it should be that one. Let me see. I think we're going to have a negative exponent. If we distribute that x squared, the first term turns into 1, but then the second term turns into 1 over x squared, which is the same as x to the negative 2. It's not, so it should not be a polynomial because of that negative exponent that's created. Okay. Oh, that's a cube root. Yeah, that's not going to be. Remember, the powers have to be integer exponents. The cube root of x squared is really the same as x to the power of 2/3. So it's not a polynomial function because of C. That cube root should be that one. Thing still has not resolved itself. Should have, there it is. I click on here, there it is. Okay. All right, so is the graph, let me see. I don't know how, we might get to this one kind of quickly. Is the graph on the right the graph of a polynomial function? No, right? You have a vertical asymptote. We're going to say no. Okay. Cannot be the graph. There's a hole or a gap or a break. It's not continuous. So B, right? Hopefully I'm not going too fast for you guys. Match the following polynomial function with the graph. Use the leading term test and the y-intercept. So the leading term test, right? We got this negative x to the 8, right? So if we just focus on the leading term, the leading coefficient is what? Negative. So that means our graph goes down to the right. And the degree of this polynomial is 8, which is even. So that means the other side does the exact same thing. So this graph should fall to the right and fall to the left. The y-intercept, if we set x equal to 0, is going to be -2. Okay. And then we said it falls to the right and falls to the left. So I think there's a poll. Let me relaunch the poll. Okay. There. I guess I'm gonna have to zoom out on this again. I know it's making the text real small. That's what I was trying to avoid, but you know. So, you know, do the best you can with the text. But it should be large enough to where you can see what you need to see. So which one is the graph, right? We said it should fall to the right and fall to the left. I think we're still getting unanimously answer choice A, so we're going to go with that. Okay. Next question. So it says match the following polynomial with the graph. It would be nice if I could rearrange those to stack them. Oh, maybe I can do that. Maybe that'll help. Okay, let's try like this. And then what we can do is go like this and move this guy over here. It's still that. It's still not all the way. I know what I can do. That's irritating. What if I go like this? We'll give that a go. Maybe that'll work. Okay. And let me relaunch this poll. Launch. Okay. So this one asks us to match the following polynomial with the graph using the leading term test. All right. So the leading coefficient is positive. So that tells us we should go up to the right. The degree of the polynomial is even. So the other side does the exact same. So it can't be B or D. And then if we think about the y-intercept, if you think about the y-intercept, is it A or is it C? All right, it can't be D. I think B is out. So yeah, I think I'm gonna go with A, right? Because the y-intercept is 8. C is closer to like 29 or something like that. So we're gonna go with this. All right. So the y-intercept here, I'm gonna just suppress this for right now. And I guess we can go like this. The y-intercept here is what, 7? If you let, come on. If you let x be 0. What's the time? Let me check this one. Well, let's finish this one out. So like this. Let me relaunch this poll. Like 29 or something like that. I always hit the play button. So we're gonna go with this. Relaunch, launch. Okay. So which is the leading term? Okay, there's a vote for A. Let me see. The leading coefficient is positive, so it goes up to the right. A is promising. Oh, but then the degree of the polynomial is 3, which is odd. So that means the other side does the opposite. So it can't be A and it can't be D. So then I think that leaves us with C. We're going to go with C. Okay. Let's go into the next question. Polynomial function lists each real zero and its multiplicity. Okay, so this one's not really a poll. We're going to go like this. Okay, that seems like it's working a little bit better. For the polynomial function below, list each real zero and its multiplicities. Okay, determine whether the graph crosses the x-axis. So hopefully, you watched my recorded lecture on this, or you just made your way through this section, because on Monday, we only had so much time to get through the section. We only made it about halfway through the section, right? So there's a lot of other stuff that's there that we didn't talk about in class time just because of due to time restraints, but you're still responsible for it, right? So for instance, one of them here is like the multiplicity. So this function is already in factored form, right? So then the multiplicity, like how you have this x plus 5 squared, that means for that 0, when x is -5, its multiplicity is 2, all right? So what that means, when it has an even multiplicity, like that power of 2 like that, when it has an even multiplicity, what that means is that 0 or that x-intercept is going to bounce off the x-axis. So it's going to touch the x-axis and turn and go back the other way. It's going to bounce off the x-axis versus the first 0 when x is 7, because that's raised to the power of 1. What that means is going to cross the x-axis, all right? So we have 3 zeros. One of the zeros crosses the x-axis. The other 0 bounces off the x-axis. So the one with the even multiplicity bounces. The one with the odd multiplicity crosses. Type the zeros in the box, use a comma to separate. So if we set this to 0 and solve, we would get 7 and -5. Okay. And then the multiplicity of 7 is 1. And if that's not clear, you have to ask. Oh, I'm supposed to check Zoom. And then what the multiplicity of -5 is 2. Okay. So when x is 7, because the multiplicity is odd, it's going to cross the x-axis. Okay. And then when x is -5, because the multiplicity is even, it's going to bounce off the x-axis or touch the x-axis and turn around. Okay. Let's go on to the next question and let me check Zoom. Let's see. Let's close this. Let me see. We do have some stragglers. Okay, cool. Close. Cool. All right. Let's suppress that. Okay. So for this polynomial function, find the zeros and its multiplicity, same kind of deal, right? So this one, I guess I can zoom in. Zoom in twice. For a better view. There we go. Okay, that's a little bit better. If I can suppress this header or make that, I don't know. Anyway. So we have this polynomial. So the 0, right? Fortunately, it's already in factored form. If we set it to 0 and solve, we would invoke the 0 factor property. You can just look at this and get the zeros. So from that first binomial, you get x is 1. And that second one, you get x is -4. Okay. So the multiplicity of 1, so you have x minus 1 to the power of 3. That means the multiplicity when x is 1 is going to be 3 because of that power of 3. Okay. So then that means the multiplicity of -4 is 2. Okay. So then again, what the multiplicity tells us, it tells us how the graph behaves at the x-intercepts. The graph, so when x is 1, because the multiplicity is odd, that means it's going to cross the x-axis. Okay. And then when x is -4, because the multiplicity is even, it's going to bounce or touch. Okay. Number of turning points, right? So if we think about, like, if we had y equals x squared, we have at most 1 turning point, right? Like if we think about a parabola, we have at most 1 turning point. If we think about y equals x cubed, where it's like it could take on an S shape, right? So you can have a peak and a valley. You can have at most 2 turning points, right? So whatever the degree of our polynomial is, we can have at most n minus 1 turning points, right? So with this, if we were to expand this all the way out, we would have an x cubed term times an x squared term. These are the highest powers for each of those binomial factors. X cubed times x squared gives us x to the 5th. So that means that the degree of this polynomial is x to the 5. So if the degree of this guy is x to the 5, then that means we have at most 4 turning points. Okay. That was a little bit of an adventure. Hopefully, we were all aboard and not all bored. Determine the real zeros of this polynomial and their multiplicity. Okay, so we have an x squared. If we were to distribute, we would eventually get an x to the 4. Let's see, can we factor that second polynomial? 2 numbers, no, right? 2 numbers that multiply to give us -4. Because if you did -4 and 1, the other one should be a 3, but it's not there. And if you did -2 and 2, they add to 0, right? So the second one cannot be factored. So let me think about. We could try the quadratic formula. Let me see if we did -b plus or minus the square root of b squared minus 4 times a times c. Yeah, not a real zero. Let me think about something. It's a U-shaped curve and it goes down. Let me think. -b plus or minus the square root of b squared minus 4 times a times c. Well, I think we might get one there if we use a quadratic formula. The first one is straightforward. The second one, I just want to do the quadratic formula really quickly. So if I did -b, that would be -1. Let me see. Can I do plus or minus? Plus or minus? No? Okay, that's okay. I'm going to just abbreviate it like this. Plus or minus. -b plus or minus the square root. B squared is going to be 1 minus 4 times a times c, which is -4. And I'm just doing this, just so we can see it. I probably should be like writing this out. How do I get rid of that? Okay. Okay, I want parentheses. There we go. So b squared minus 4 times a times c. And then we really want to do all of that. This isn't all the way right. I'm just doing this for notes. -b or b squared, heck on it. -b plus or minus the square root of b squared minus 4ac all over 2a. So divided by 2. Okay. So if we were to crunch, thank you. If we were to crunch this number, so you get a double negative becomes positive, that's 16 plus 1 is 17. So that's really the square root of 17, all of that guy right here. This is all the square root of 17. I was like, I need to write it out on some fashion so I could see it. Then that's plus or minus. The real zeros, use a comma to separate, use integers or fractions for any number in the expression type, using radicals as needed. Okay. So I think we had a total, let me zoom out some. I think that should be good. this. Come on. Okay, there it is. Now it's not gonna not let me do that. Okay. So from the first term, from the x squared, the 0 is 0, right? We get 0 from there. But then this guy, we get -1 plus or minus square root of 17 over 2. So this is the first one, and then I'm gonna hit comma and then type it again. Now I didn't exclusively write it out. I did kind of write it out in my own way. I know that may have been a little bit challenging to follow. And then we're gonna say plus the square root of 17 divided by 2. Okay. If I need to like redo that, because I didn't exclusively show you guys the quadratic formula. If I need to write this stuff out, just say so, and I'll go back and like show the details. Let's figure out where we went wrong. I think the first one is fine. Let me check that discriminant again. B squared, which is 1, minus 4 times A times C. So that's plus 16. That's a 17, all over 2A, all over 2, right? Oh, it's because of the way I typed it right here. So instead, it's really supposed to be all over 2. And so it's really supposed to be this -1 over 2. And then this guy is supposed to be over 2 as well, right? Because I was writing it improperly, so I didn't see it. All right, I should have written it properly. Okay. So then, let's see. I think the multiplicity of both of them, no. Farthest to the left. So the 0 furthest to the left, it comes from the square root. It's odd, right? That one occurs once. The only one that has an even multiplicity is the 0. The other two are odd. So that multiplicity is 1. Okay. The multiplicity is 0. The middle one is the 0. So that multiplicity is 2 from the x squared. Okay. And then the farthest right is also 1. So how many times does that 0 occur? Right. So the leftmost is going to cross. When it has an odd multiplicity, it crosses the x-axis. The middle 0, because it's even, is going to bounce off the x-axis. And the rightmost 0 is going to cross again because it has an odd multiplicity. Okay. Okay. So we're actually using the intermediate value theorem to show that this polynomial has a real 0 between 1 and 2 and approximate the 0 to 2 decimal places. So intermediate value theorem states that, like, if we have a polynomial, because polynomials are smooth, continuous, unbroken curves, then if we evaluate this polynomial at these endpoints of 1 and 2, as long as they have opposite signs, then that means that somewhere between 1 and 2, there has to be an x that crosses the x-axis. So there has to be a 0, at least one 0 between 1 and 2. So I think I'm gonna just use my calculator. I can have it here. Okay. So let me refresh and reload. Okay. So first I'm gonna go to my y equals and put in this polynomial, which is 2x to the power of 4 minus 2x to the power of 3. Nope, I missed my x. Minus 14. Okay. Okay. Trying to think of. Because I have one way to do it in the calculator. I was trying to think of like how to go about it without the calculator. I mean, other than like guess and check. Let me do it in my calculator. So I'm just gonna hit graph. It should cross between 1 and 2. Okay, it looks like it did. So then I'm just gonna go to calculate and I'm gonna hit number 2 for 0. So then I want a left bound so now I'm on the left side of my 0. I'm going to go to the right side of my 0, hit enter, and then choose a guess, and it gives me, it says 2 decimal places, 947. So that 7 tells me to round up. So we should get 1.95. Now, okay. So another way to go about it, it just dawned on me, right? You could look at the table, right? You could make a table of values. I think that that's the way the book does it. So let me kind of let me mirror that really quickly. So we got a result of 1.95. So I'm not going to hit enter. I just want to type it in. So now if we were making a table, like we would look at the table and we would have the table go from 1 to 2 and change by 0.1, right? So I'm going to go to table set. I want the table to start at 1 and I wanted to change by 0.1. Okay. So then I want to go look at the table and you can do all this manually, like, you know, plug in these different values. And so somewhere between 1 and 2, the sign should change, right? So you see the result, all the outputs right now are negative and it should go positive before we get to 2, right? So now we see that between 1.9 and 2, the sign changed. So then I'm gonna go back to my table. Now I want the table to start at 1.9 and now I want it to change by 0.01. So I'm like zooming in, right? So now if I go back to the table, okay, so somewhere between 1.9 and 2, the sign should change, all right? So right here, between 1.94 and 1.95, the sign changes. I'm gonna do it one more time, right? Because we want 2 decimal places, so we need one more place value or whatever. So I'm gonna go, I want the table to start at 1.94. So I wanted to start at 1.94. And now I wanted to change by 0.001. Okay. So now when I go back and look at my table, we should get a sign change again. So basically I just keep zooming in and in until I get my desired right there. So between 1.947 and 1.948, the sign changes, but both of those round to 1.95, right? So we know the 0 is somewhere between these two, but since we want 2 decimal places, both of these guys round to 1.95. So that's the way I think that they do it. That's why I was kind of pausing. I was trying to remember how they went about it. And I recall something of that nature, right? You saw how we got that result with the graph, and you know, it can give you an approximation of the 0 quickly, or you can use that table technique, you know. So if you don't have a graphing calculator, you can also do that in Excel. You can do that same technique in Excel. Okay, I think we got another one. Maybe I might do Excel or numbers or something like that. Because you can do formulas. So Excel is actually like a calculator. If you know how to type in the formulas, maybe we might do a demo on it. Use the intermediate value theorem to check whether a polynomial function given below has a 0 on this interval. If it does have a 0, approximate to 2 decimal places, right? So between 1 and 2, so this is kind of a repeat. I don't know if you guys, if you guys want to see the demo in Excel, if you say yes, I'll go ahead and do it. If you guys stay mute, then I'm just going to do it the quick way. But knowing how to do things in Excel is actually a powerful asset. I use it for like budgets and all sorts of things. I mean, it's a calculator and it's like a spreadsheet. So you can like type in formulas and it'll do calculations for you. Honestly, that's how I calculate you guys' grades. I pull the data as far as whatever scores you have, and then I create formulas to find averages and things of that nature. And I use Excel I use numbers, but it's the same as Excel to calculate your grades. So let me check Zoom really quickly. See if we got any scragglers. I get them. Got them, coach. Good. Right here. Okay. So let's see. I'm just going to do the quick way. Let's zoom. I want this guy just for the sake of time. So I'm going to go back to my y equals, and I'm going to put in that polynomial 2x to the power of 5 minus 3x squared. I want to do it the more generic way because I know that everybody doesn't have access to this 283 plus, but you should be able to, like, I know you have Excel because it's a part of our package suite with the school. So I know you have Excel and you can make tables there. So I'm going to do the table here. 2x to the power of 5 minus 3x squared, because I know that that's the way that more people would have to do it. Everybody doesn't have an 83 plus or even the ROM. This took effort to like get working. I had to download a ROM. This site is called chemtech.net. It's an emulator that was made by some other school, and I've been using it for years and it's been working great. So it's a virtual calculator. So I'm going to go to my table set, and I wanted to start at 1. I wanted to start at 1, and I wanted to change by 0.1. And let's look at the table. Okay. So somewhere between 1 and 2, we should get a sign change. You can see it right there between 1.4 and 1.5. Okay. So I'm going to go back to my table set, and I wanted to start at 1.4, and now I wanted to change by 0.01. So I'm zooming in. If I go back to the table now, we should get another sign change between, I think it's between 1.4 and 1.5, right? We should get a sign change. Okay, there it is, all right? So the sign change is between 1.48 and 1.49. So if we're rounded to 2 decimal places, we need to do this procedure one more time. So now we wanted to start at 1.48. So I'm gonna go to table set. I wanted to start at 1.48. And now I wanted to change by 0.001, just like we did in the previous. Okay. If I go back to my table, so now we're just trying to get that 3rd decimal place. It should be a sign change within the next 10. And there it is. Okay. So between 1.489 and 1.490, we get a sign change. Both of those numbers round to 1.49, right? It's between these two numbers, but these both round to 1.49. So we're going to submit 1.49 and go with that. 1.49. Okay. I think we got time. We got time for 1 or 2 more. For this function, answer the following question, in graph behavior, right? So first we start with the leading term, or really the leading coefficient. The leading term is going to be the x to the 6. So the leading coefficient is a 1, which is positive. So that means it goes up to the right. Because the degree of this polynomial, which is 6, is even, that means the other side does the exact same. So we should go up to the right and up to the left. So it rises to the left and rises to the right. I'm going with A. Okay. We got time. Let's see what else we got. Sketch the graph. So up to the right, up to the left. So we know it can't be C. The y-intercept, right? If we let x be 0, the y-intercept is the origin. So it can't be D because D doesn't pass through the origin. So then it's either A or B. I think we just need to choose. Okay, so if we factor out, we can factor this guy. If we factor out x to the 4, we should write it out. X squared plus 3x plus 2. So 2 and 1. So then -2 and -1. All right. I think I'm gonna go with A. Basically, I'm just trying to find one more point to confirm, right? We know it's between A or B, so like I'm just choosing, like for instance, my claim is that when x is, I think it's when it's like -2, we should get a 0, and when x is -1. I'm gonna just kind of go with it because when I did it in my head, that's what I got. I didn't write it out, but you know, I was explaining the concept. I just chose, I found a few additional points and confirmed them, and it matched up the graph that way. Okay. So for this function, describe the end behavior. So first we need to identify the leading term, right? So the way it's written, the actual leading term is a little bit deceptive. We need to expand this out. If we expand this, we're going to get -5x to the power of 3, right? Not squared. So because the leading term is -5x cubed, that -5 tells us it falls to the right. Because the degree of the polynomial is 3, that means the other side does the opposite. So it rises to the left and falls to the right. Rises to the left and falls to the right. The only one that does that is A. Okay. So these are just concepts. sketch the graph using the graphing tool. Well, we know it's an S-shaped curve and it's already factored for us. So we can identify our zeros. It should be this S-shaped tool here. Okay, I need to redo that. Cancel. This is this guy. All right. So for instance, when x is -1, that's one of our zeros. I think we're here. Can I type to edit? Remove it? No. Let's cancel. Let's try it again. So we need to plot 3 points basically. I'm trying to get, can I zoom in? Let's see. This, okay, here. All right, okay. So we know that when x is -1, that's one of our zeros. And it's gonna cross there. When x is 0, that's another one of our zeros, okay? And then we just need like one additional point, I guess. Oh, we need 2 more, okay. So when it's -1, we know it's gonna cross. So there is a point between -1 and 0, but that one's not gonna be nasty to try to do. Let's do when x is 2. It's gonna be challenging. Like we kind of need to zoom in. So let's see. When x is 1, 5 times 2 is 10, right? So when x is 1, hang on, -10. So when x is 1, we're at -10. Okay. Let's say I would really like to get a point between those guys, but I feel like the half would be too much of a challenge unless it would allow us to type our points in. And I'm gonna do when x is, let's do -2. So if we do, if x is -2, we get what, -1, we get 4, -20, so then -20, and it's off the chart, so we can't use that one. 0, we need one more point. We did -1, we did 0, we did 1. Let's try when x is 2. No, but there's not a 0 there. So that should go off the chart as well. We tried -2. This other one, this final one is like nearly impossible to get because it's so small. And we need to be able to type it. That's the thing. Or move it retroactively. Let me see. We need one more. And we really need like -1/2 is the one that we need to do. If we did a -1/2, we would have a -1/2 there. That would be 1/4, so a -5/4 times 1/2 is a -5/8. Let's see, I can't put that in here. Let me think, what else could I do? It should go down to the right and up to the left. Let me think, give me a moment. Because -2 goes off the chart. Let me try it down to the right, up to the left. Is there a way to zoom in? Click the curve to plot the last point. I'm just gonna click somewhere. I know it's like, it needs to bounce. We need something slightly to the left of -1. Let's try -1.5. I'm just trying to wrap with this one. If we do -1.5, that's going to be a -1/2. Let me see, 3/2, 9/4. See, that gets to be weird. I'm just gonna click over here. Like, I know that's not exact. Okay, so I can move it. Okay, so that's the one that we need to try to get. That's the final one that we need. Okay, it looks like we can do the halves. Let me use my calculator, see if I can get that number exact. So then I'm going to do -5. Let's put it here, y equals -5 x squared, parentheses, x plus 1. Okay. Let's quit. And I want to see when x is negative, let's do negative 1.5, because I think that's going to be on our chart. See 5, and let's do it math as a fraction. Okay, let's go back. We get this result. I'm going to say -5, and I'm going to hit math as a fraction. So 5 and 5/8. See, that's the one that you can't, that you need, that you can't graph. What if we do when x is -2? And I think -2 goes off the chart. I think that's what we said there. -2 is 20, right? Let's try. It said -1/2, but that's not, we can't get to that one. Negative 1.5. Oh, right here. Yeah. 625. Like, if we could just type that one in, then we can get there. Let me see. So we got 5.625. No, where'd it go? Right there. No. 0, 0. Okay. So it's this guy. Let's see. We need to be able to type that one. Delete it, move it with arrows. Oh, let's see if we do it by arrows. Oh, it's so close. Oh my goodness, that's irritating. Yeah, we just need to be able to type that. I might have to change the settings. Okay, so I guess if well, the thing is, because I know this is going to mark it wrong and it's not letting me type what I need to type, is this guy. That needs to be, I need to be able to type that. So with something like this, you know, for the homework, it'll be what it is. Usually with the exams, what I do is remove the interactive figures, and I want to say something like this will pop up on the interactive figure, so I would get rid of it. I know it's going to mark it wrong because I can't get that point proper. I just want to see what it says. It's no symmetry. Oh, dang! I didn't even think about that. There's a point. I never tested the point between -1 and 0 to get that point below. I'm tempted to try it again. I'm going to try it again. I got like a full minute. I'm gonna go quickly. You got, if you need to go, you can go, obviously. In-graph behavior, down to the right. Let's see, and then up to the left. Okay, let's go with A. I'm gonna see if I can get it. Click the graph. Okay, real quick. So we know it's this tool. When x is -2, that's one of our zeros. So that's it's here. Okay. X is 0. The origin is another 0. Okay. Let's see. When x is 1, 3 times -8, that goes off the chart. When x is -1, we're at 1. We're at -8. So -1, -8 is here. One of the points I accidentally clicked. Can I remove that one? That's fine. Just try it again. So we got the origin. Dang, did I click 2? Okay. Let me just click 3 points and just position them individually. So we know we got the origin, right? We know we got -2 is a 0, so that's here. Okay. I think we said when x was -1, I think we get like -8. So -1, -8. There. Okay, so we got that one. Let's see. We said falls to the right. So that should bounce. So then like a half. If we put in a half, I think if we put in x is 1, it goes off the chart. That's a 3. 8 times 3 is negative 24. So then if we do a half, let's try when x is a half. And what I'm going to do is go here, my y equals negative 8. Negative 8x, come on. Negative 8x squared, parentheses x plus 2. I'll give myself just a moment. And when x is a half, let's change. You can hit delete or change it to a 0. Negative 3. Okay, cool. We got a clean one. So, oh, we did a negative 1/2. I'm going to do positive 1/2. Okay, so when x is a half, y is negative 5, right? So this one would be 1/2 and negative 5. Boom. Cool. 1/2 negative 5. Okay, so we got this one. I'm confident in this one. It's doing the right stuff. I'm gonna go with it. If it's wrong, I think I know what to fix. Okay, cool. So if I'm able to do it, okay. So what that means is, I know I acknowledge the challenge there because it is a little bit, because it's you really need to be able to type those points in. And I thought I usually have that setting to allow you to type the points in. But usually what I've been doing, if the interactive figures pop up on the exams, I've just been removing them. That's a simple thing. That's just the nature of how these things are, okay? But it is possible to do it. I did it. You get unlimited attempts, so, that's how that goes. Just do the best you can with it. More than likely, if there's an interactive figure on our exam, I will probably remove it, okay? Are there any questions before we go our separate ways? Okay. I don't think we necessarily wrote anything. We didn't have any written notes. So with that, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your day. Okay, guys? Take care. Peace.
Have a nice day.
You as well.
Thank you.
Mm-hmm.